r a bar x plus phi minus phi a bar phi plus z minus 0 a bar z, right? So what is that vector? Vector r bar is equal to minus r a bar r plus z a bar z, right? So this is the vector. Now from that we can write a bar r. A bar r is the unit vector, right? So a bar r is equal to actually unit vector is vector upon magnitude. So this is going to be minus r a bar r plus z a bar z divided by under root r square plus z square, right? So this is your answer. Is it visible? Is it audible? Is it okay what I have solved on this screen?
Yes, sir. It is visible and audible.
Okay, fine, fine. So understood the problem, how you can find the unit vector. Actually, this is very basic thing which comes in, let's say in unit 1. But I just want to just recall the concept of unit vector. That's why I just have revised it, right? So shall we proceed?
Okay, sir.
So let us take a new example. It is a little bit complicated. So you can consider this is a 6-mark question actually being asked in university examination, right? So let us let me save this. Save करायची गरज नाही आहे तशी. This new. So example is a uniform line charge नाही एक्झाम्पल समोर दिसत असेल तर सॉल्व करायला इझी जातं. A uniform line charge rho L is equal to 25 nanocoulomb per meter lies on the line x is equal to -3 and z is equal to 4 in free space, right? So find E bar, find E bar. So electric field intensity is to be calculated. So find E bar at number 1, find E bar at first at the origin, and second you need to find at P, let's say 2, 15, 3. So you need to find the electric field intensity because of this line charge at 2 different locations. One is at origin and second one is at point P. Right. So to solve this, since line charge is given, so what formula you can use? The formula that you are going to use is E bar is equal to, right? In last lecture we have studied this derivation. So E bar is equal to, what is that formula? Rho L upon 2 pi epsilon naught r a bar r, right? So this formula we are going to use, right? So to use this formula we should know the vectors first, because we just have to calculate the unit vector. You have to put the magnitude over here, right? So that's why we require the this unit vector, and for that we should follow our conventional steps. In that, first is to draw a neat diagram, right? So this is z axis, y x-axis, right? So the point is given where this uniform line charge actually passes through, right? So the point is, what they have mentioned is, the point is x equal to -3 and z is equal to z is equal to 4. So we have to locate this point. So the point would be somewhere here, because if I extend this x-axis on a negative side, right? So this -3 would be somewhere here. So this is -3, right? And if I find z is equal to 4, it would be somewhere here, right? So at this point, if I extend back, I would get the point somewhere here, right? So at this point, value of x is -3 and value of z is +4, right? And we know that the line charge is passing through this point. Line charge is passing through this point. So that I can draw the line charge here. So this is your line charge which is passing through this point, right? Now on this line charge, what density is present? Rho L is equal to 25 nanocoulomb per meter, right? So this is the density present on this line. So because of this line charge, what is the electric field intensity produced at origin? That we need to find. And in order to find the electric field intensity at origin, we must extend the vector from the point, right? So if I extend this vector from given point, I would get this vector, right? So let us assume this is R1, sorry, R bar, right? So first step is to calculate R bar, right? So how do you calculate R bar? If you calculate R bar is equal to, what are the coordinates? Coordinates present over here. The coordinates are coordinates of origin 0, 0, 0. What are the coordinates of this point? This point is -3, 0, 4. So if you know the coordinates, you can find out the vector R bar. To find out this vector R bar, you can subtract, you can do the subtraction. So this vector R bar is equal to 3 a bar x minus 4 a bar y, right? So unit vector of this a bar r is equal to, a bar r is equal to 3 a bar x minus 4 a bar y, sorry, minus 4 a bar z, sorry, this is going to be z, a bar z. Right, so you got the electric this unit vector and vector, right? So you can find out now electric field intensity. The formula I have given you, E bar is equal to rho L upon 2 pi epsilon naught R A bar R. So put the value of rho L. Rho L is 25 nanocoulomb. So 25 nanocoulomb means 25 into 10 raised to minus 9, right? Divided by 2 pi into 10 raised to minus 9 upon 36 pi, right? Into what is the magnitude? I'm sorry, I have not written the magnitude. If you calculate the magnitude would be 5, right? So here I can write the value of R. Value of R is 5 into unit vector is 3 a bar x minus 4 a bar z divided by 5. Right? So can you calculate this by using calculator? You can calculate this thing first. And finally, you can get this divided by your answer. Right? So what electric field intensity you are getting? E bar is equal to, I will give you the answer for verification. E bar is equal to 54 A bar X minus 72 A bar Z. Unit of this is volts per meter. So this electric field intensity at origin. So this is answer of first. Clear? Understood how we can find out the electric field intensity at origin? Is there any doubt up till now?
नो सर.
समजलं सर्वांना? कुणाला नाही समजलं असे कोणी आहेत का? ठीक है. So we will proceed. Now second part of this example is to find the electric field intensity at point somewhere else. What is that point? 2, 15, 3. Right. So first of all, we will draw the XYZ coordinates. So this is XYZ. And we know that the point is here. So my X is equal to -3 and Z is equal to +4. And the line charge is passing through this point. Right. On this line, X is equal to -3 and Z is equal to 4. Right. And rho L is equal to 25 nanocoulomb per meter. Right. This is already given. Now in the second part of this, we need to find the electric field intensity at point P. And the point P is located somewhere here. Right, because the coordinates of point P are, what are the coordinates? Point P, coordinates of point P काय झालं याला? चालू नाही, काय होतं याच्यावरती 2 बटन्स आहेत, ते प्रेस झालं तर कंटिन्युअस रायटिंग सुरू होतं. Right, so the point P is located here. The coordinates of point P are 2, 15, 3. Right, so these are the coordinates of point P. Now, to obtain the electric field intensity at this point, you need to extend a perpendicular on the line charge. Right. So if I extend this line charge, if I extend this point on a line charge, what point I'm getting? So I'm just extending a perpendicular on line charge. So you get another point. So what would be the coordinates of this point? The coordinates of this point will be X value, we will take it from line charge. So X is -3. Y value, we will take it from P. So Y value will be 15. And Z value, we will take it from line charge, that is 4. So these are the coordinates of new point. So if we get those 2 points, we will be able to find out this vector. So let us say this is vector R bar. Right? Now we are calculating this vector R bar. So R bar is equal to, so this is equal to, if you do the subtraction, 5 A bar X minus A bar Z. right? Divided, then unit vector you can calculate a bar r is equal to 5 a bar x minus a bar z divided by under root 26, right? So this is a unit vector. Now you can use the formula E bar is equal to rho L upon 2 pi epsilon naught R A bar R. This is the formula for finding electric field intensity due to line charge, right? So by putting the values into this expression, E bar is equal to 25 into 10 raised to minus 9. This is what the value of rho L is given. Then 2 pi into 10 raised to minus 9 upon 36 pi into under root 26 is the value of R. It's I think it's not a square, right? Into unit vector. So what is unit vector? Unit vector is 5 a bar x minus a bar z divided by under root 26, right? So calculate the answer and tell me the final answer for E bar, right? So for that you need to calculate this thing first and get it divided by the numerator. I will write the answer for verification. 86.55 a bar x minus 17.31 a bar z, right? So unit is volts per meter.
Got it, sir.
Got it? Any doubt so far? Other students?
No, sir.
No doubt. If no doubt, we will proceed further. So let me just save it. Now the point that I'm going to teach now is very important. Like we have done the electric field intensity for a line charge. We have calculated it for line charge. Now today we are going to derive the expression for electric field intensity because of surface charge, right? So be a little bit attentive and try to understand what I'm saying, how we can proceed, how we can start for derivation of this thing. So we have the point somewhere here, right? And I want to find the electric field intensity at this point because of a surface charge, right? So let us assume this is surface and the charge is uniformly distributed on it. And because of this line charge, how much is the electric field intensity produced at this point that I want to find, right? Earlier, we have done with point charges, right? So electric field intensity at a particular point because of point charge is, it can be calculated. If this is Q, I can find the electric field intensity at this point because of this Q. How I can find? E bar is equal to Q upon 4 pi epsilon naught R square A bar R, right? So this is how if point charge is given, right? Then second, yesterday, day before yesterday, we have calculated if line charge is given. And if you want to find the electric field intensity at this point because of this line, how you can find out? You can select a small segment of this. So let us treat this as dq and then find out differential electric field intensity and then integrate it. So rather than doing this, we have just came across a certain expression to obtain the final electric field intensity. So that is electric field intensity E bar is equal to rho L upon 2 pi epsilon naught r a bar r. Right? So this is in the case of line charge. Now today we are going to derive the expression for surface. So because of this surface, how much is the electric field intensity produced at this point, that we are going to derive, right? So to derive this, what would be the assumptions? How we can proceed? Can anyone tell? How we can produce? We can derive? How we can start actually? So first thing is we should start with coordinate system, that is rectangular coordinate system, and then we will switch to cylindrical coordinate system, right? So this is x-axis, this is y, and this is z. And let us assume the surface is placed on xy plane. So this is your xy plane, the surface on which the charge is uniformly distributed here. And because of this surface, we want the electric field intensity at a point. Let us assume that point on z-axis somewhere here. So let us say this point is P. So what would be the coordinates of point P if I consider rectangular coordinate system? It would be 0, 0, z. And if I consider this as a spherical coordinate system, then cylindrical coordinate system, then it would have 0, 5, z are the coordinates. So cylindrical coordinate system, right? So at this point we want the electric field intensity because of this entire surface charge. Now this surface charge, we know the procedure. The steps are to divide, to select a small segment, a small area of this surface. So I'm going to just select a small area from this surface. So let us say I have selected this surface, and area of this surface is ds, and the charge which is present on this surface, we would call it as a dq. And what would be the value of dq if rho s is the density? Rho s is the surface charge density present on this surface. In that case, dq will be equal to rho s ds. Right? So, is there any point? Is there any query up till now? Understood what we are going to do? Because of this small surface ds, we are going to find the electric field intensity at point P. So that would be differential electric field intensity. And then we are going to integrate that, right? So just to proceed with that, let me just draw the vector that is originating from this small surface ds from this point to the point P. Right? So first step, we are going to find this vector r bar. Then we will try to find the electric field intensity, differential electric field intensity because of this dq, and then we will integrate it, right? So just to proceed with that, you can put a heading. What is that? Electric field intensity E bar due to infinite sheet charge or surface charge, right? So first step is to find the vector r bar. R bar is equal to, so you know the coordinates. What are the coordinates of let us assume the coordinates of this ds, as since it is on xy plane in a cylindrical coordinate system. What coordinates I can assume here? It would have r, it would have value of r because it is away from origin and z axis, so radius would be there. Then it would have angle phi, and since it is on xy plane, value of z, that is height, is 0. So we got the coordinates r, phi, 0 are the coordinates of dq, and 0, phi, z are the coordinates of point P. So now we can find the vector r bar. So vector r bar is equal to 0 minus r a bar r. 0 minus r a bar r plus phi minus phi, 0 of course. So phi minus phi a bar phi plus z minus 0, z minus 0 a bar z, right? So this is the vector. If I simplify this, what vector you are getting? Minus r a bar r plus z a bar z is the vector that you are getting. So from this I would like to write the unit vector a bar r. Unit vector a bar r is equal to minus r a bar r plus z a bar z divided by under root r square plus z square. Any doubt so far? Any doubt up till now? I have calculated the unit vector of that vector. Any doubt so far?
No, sir.
Okay. So next step is to use next step. What is that? We have to find the differential electric field intensity. So this step we have already written. dE bar. dE bar is equal to what we can write is dQ upon 4 pi epsilon naught r square a bar r. Right. By writing the values, I can say that this dE bar is equal to, what is the value of dQ? dQ is rho s ds. So rho s ds. Now here I want to replace this ds. Since we are talking about ds when z is constant. So you can go back and you can tell me the value of ds if z is constant, right? So this is from unit 1, differential surface of cylindrical coordinate system. Characteristics I have given you. Differential surface when z is constant, what would be the value of ds? Value of ds would be
R dr
r dr.
d phi.
Correct. R dr d phi. I'm just taking magnitude. I'm not taking direction. So that a bar z will not be there. So ds is equal to r dr d phi. So you can put instead of ds, I can write here r dr d phi divided by, this is the value of dq, divided by 4 pi epsilon naught r square plus z square into bracket, this is unit vector now, minus r a bar r plus z a bar z divided by under root r square plus z square. Right. So this is what we get as a differential electric field intensity at point P because of a small surface ds, which is having a charge dq. Right. So this is the differential electric field intensity at point P. Now this we have calculated just for a small surface ds. Now we have to understand, because since it is symmetrically placed on this xy plane, very similar to this ds, we have equally opposite at a symmetrically opposite side. On this side we have another ds, right? This ds would have its own component, right, in which this r is going to be cancelled because of this r. So radial components are going to be cancelled and only vertical components are going to be added. So from this expression, if I show you this r component, this radial component is going to be cancelled. and only Z components are going to be added. Understood? In last expression, in last derivation, what we have assumed, since the line is placed on Z axis, plus Z is cancelled by minus Z, and only radial components we have added in last time, like finding electric field intensity due to line charge. But exactly opposite of here, opposite of that, here radial components are going to be cancelled and only vertical components are going to be added. That means a bar r term is going to be cancelled. Only this a bar z is going to be there if we integrate it. That is what we are talking about, the total electric field intensity because of this entire surface. How you can find out this? By integrating this differential electric field. While integrating this, we have to cancel it, because for every point, so let us assume I have point somewhere here. So if I select ds here, exactly opposite ds will be present there. So this ds, radial component of this ds, will be cancelled by radial component of this ds, right? Understood why I'm cancelling this radial component? Only vertical components will get added while doing integration, right? So let us proceed to integrate this by cancelling radial component. Any doubt why I have cancelled this radial component? Understood why I have done this? बघा मी I'll repeat in मराठी. ds आपण या ठिकाणी घेतला, ठीक आहे. सो दिस इज युअर ds. याच्यामध्ये रॅडियल कॉम्पोनंट पण आला, हा झाला रॅडियल कॉम्पोनंट, आणि त्यानंतर व्हर्टिकल कॉम्पोनंट पण आलेला आहे, ठीक आहे. पण ज्यावेळी आपण टोटल इलेक्ट्रिक फील्ड फाइंड आउट करत असतो त्यावेळी आपल्याला सगळ्या सरफेसला इंटिग्रेट करायचं आहे. त्यावेळी आपल्याकडे मागच्या साईडला जो आहे हा ds, याचा रेडियल कंपोनंट पण कन्सिडर केला पाहिजे जो इथं आहे. हा रेडियल कंपोनंट या रेडियल कंपोनंटला कॅन्सल करेल. समजताय? सो दोज सिमेट्रिकली अपोजिट radial components are getting cancelled. So only the thing is the vertical components are going to be added. So that's why we have cancelled this one. And we will add a bar z term only. Right? So next, we have to integrate this. Now, as I said, whenever it is a surface, we are trying to integrate, it will be a double integration, right? If you remember, I have told you this E bar is equal to. Now I am going to take a double integration. Now double integration. So what would be the limit? What is constant actually? The constant is z. And what variables are there? Variables are r and phi. So what is the limit for r? Or let's say what is the limit for phi? Phi is the angle measured from this x-axis, right? So x would this phi would start from 0 and it would end at 2 pi, right? So limits of this phi will be 0 to 2 pi. 0 to 2 pi. And what are the limits of r? Limit of r will start from 0, it will end at infinity. So I can write the limits for this 0 to infinity, right? Next is the term that we have obtained as a differential electric field. So that is rho s, then ds, in place of ds we have written r dr d phi divided by 4 pi epsilon naught. Now, rather than writing those two terms separately, I will write r square plus z square raised to 3 by 2 z a bar z. Right? So any doubt up till now how I have written the limits? बघा मी सरफेस चार्ज जर असेल तर त्यावेळी इंटिग्रेट करताना डबल इंटिग्रेशन घ्यायचं असं सांगितलेलं. त्यानंतर हा जो सरफेस आहे तो एक्स वाय प्लेन वरती आहे. सो एक्स वाय प्लेन वरती झेड ची व्हॅल्यू कॉन्स्टंट असणार, झेड ची व्हॅल्यू 0 असणार आहे. सो वी विल हॅव व्हेरिएबल्स आर अँड फाय. आर ची व्हॅल्यू जी आहे ती 0 टू इन्फिनिटी असेल आणि फाय ची व्हॅल्यू जी आहे ती 0 टू 2 पाय असेल. समजतं इथपर्यंत हाऊ आय हॅव रिटन द लिमिट्स? एनी डाउट सो फार? Can somebody unmute and tell me if any difficulty?
No, sir.
समजलं इथपर्यंत? सर्वांना समजलंय का बघा? जर कोणाला डाऊट असतील तर अनम्यूट करून विचारा. If no doubt so far, we will proceed. So E bar. So to solve this, what we can do is E bar is equal to. So constant term, let me take it outside, rho s z a bar z upon under root 4 pi epsilon naught, right? So this is constant. Now integration 0 to 2 pi. So let me split this d phi into another integration 0 to infinity. This is for radius r dr divided by r square plus z square raised to 3 by 2, right? So just I have taken the constant terms outside and phi terms separate, r terms separate. Now to proceed with this, E bar is equal to हॅलो. हा सर बोला. चालेल, मी येतो थोड्या आणि आता लेक्चर चालू आहे, तुमच्याकडे येतो थोड्या. हा 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 हा. So E bar is equal to, so if you solve this, so what is the value of this integration? This integration would result in 2 pi, right? So rho s z a bar z upon 4 pi epsilon naught. So this would result in 2 pi integration 0 to infinity r dr upon r square plus z square raised to 3 by 2. So this 2 pi, 2 pi, 4 pi gets cancelled. So here what we get is 2, right? So this is equal to. So now what we substitution we will do here, in place of this r square plus z square, what I want to put it as a t, right? So this substitution we will do, put r square plus z square is equal to t, right? So the limits are going to be changed. So what would be the limit now? New limits. If r is equal, r tends to 0, या इक्वेशन मध्ये r ची व्हॅल्यू 0 लिहिली तर तुम्हाला t ची व्हॅल्यू काय भेटेल? t is equal to z square, बरोबर आहे? And if r tends to infinity, if r tends to infinity, what would be the value of t? T will be again infinity, right? So this is what substitution we want to make. Now this side you can do the differentiation. So differentiation, if I take, so 2r dr is equal to dt if I differentiate this. So this is differentiation of this equation. So 2r dr dt. So if I take 2 on this side, r dr is equal to dt by 2. Why I have done this? Because this r dr is the term present over here. and I want the substitution for this also, right? So r dr, in place of that, what we will write? dt by 2. This thing we can write. Now by putting the values, into the expression, E bar is equal to rho s z a bar z upon 2 epsilon naught, right, into integration z square to infinity, right? So on a numerator dt by 2, at a denominator what we have? T raised to 3 by 2, right? So now this 1 by 2, I'm going to take it outside. So this is going to be 1 by 4. So this is 1 rho s by 4, rho s z a bar z upon 4 epsilon naught. Now if I take this integration, what I could get? T raised to minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1, and here what I can write? Z square. Here I can write infinity. See how I have solved this integration. Any doubt so far? Any doubt so far? So rho s
No, sir.
z a bar z upon 4 epsilon naught. Here I can further simplify this. T raised to minus 1 by 2 divided by t raised divided by 1 by 2 z square infinity, right? So if I proceed further, so what we get? Rho s z a bar z upon 4 epsilon naught. So minus 2 I can take it outside now. Minus 2 into bracket t raised to minus 1 by 2 z square infinity. So this minus 2 and minus 4, it becomes 2. So this is equal to minus rho s z a bar z divided by 2 epsilon naught 1 upon under root t, 1 upon under root t z square infinity, right? Now next to solve this, so E bar is equal to minus rho s z a bar z upon 2 epsilon naught 1 upon under root infinity, since it is t, 1 upon under root t, so 1 upon z. So what is 1 upon infinity? 1 upon under root infinity? 1 upon under root infinity is equal to 0. So if I write this into the expression, what I get is epsilon minus rho s z a bar z upon 2 epsilon naught. Here I would get minus 1 upon z. So this is equal to, so if I take this minus minus becomes plus, z gets cancelled. So final answer for electric field intensity because of surface charge, that is ES bar, is equal to rho s upon 2 epsilon naught a bar z volts per meter. This is the total electric field intensity because of surface charge. Are you clear?
Yes, sir.
Is it understood, clearly understood? Because this is very important part of electromagnetics. How I have proceed to derive this expression. Now, I just want to recall this. Here. So the question mark now we can replace. The question mark we can replace here. This is, let us say, electric field intensity because of point charge. So let me just revise the notation. Let us redefine this notation. This is electric field intensity due to point charge. So this is EP. So this is electric field intensity due to line charge. So this is EL. And today we have derived electric field intensity because of surface charge. So this is ES. ES bar is equal to rho S upon 2 epsilon naught A bar Z. Unit would be the same, volts per meter. Understood? So this is going to be EP, this is EL, and this is ES. This is electric field intensity due to point charge. This is point charge, this is line charge, and this is surface charge. Hope you understood. So just give me feedback how today's lecture went on. Means shall we proceed with this new Wacom tool we have, and that I have used today. So just I want to get the feedback. By the time you can put your roll numbers into the chat box. Dara DR, can you unmute? Dara DR. Dara DR, just now he has joined. Dara DR, can you unmute and tell me, identify, reveal your identity? Dara DR. All of you write your roll numbers. All of you write your roll numbers into chat box. This one. Dara DR, Dara DR, Dara DR गेला.